Good morning students. Today's topic is cache memory. So first take a definition of what is cache memory. Cache memory is a small memory but very fast memory. It lies between CPU and main memory. So what is cache memory? Cache memory is a very small memory but very fast memory. It lies between CPU and main memory. So this is the definition of cache memory, and the location of cache memory is between CPU and main memory. Next question is need of cache memory. The speed of CPU is faster than main memory. So while accessing the main memory, CPU has to wait for the main memory to complete the job. Thus, there is wastage of time. Hence, the cache memory is implemented in computer system to compensate the speed difference between the memory access time and CPU. So that is the basic reason why the cache memory is used in the computer system. Next one is how the cache memory increases the speed of execution. This is the next question. The answer is cache memory store the segment of the program of data that are being executed by the CPU presently or frequently. So, by making program and that data available at rapid rate, it is possible to increase the performance rate of the computer. So, that is the basic reason why the cache memory is increased in the system, and it is shown here how the cache memory increases the speed of execution. The next topic will be performance of a cache memory. It is measured in terms of quantity called heat ratio, which is equal to number of heat by number of heat plus number of base. So we get here heat ratio, that is denoted as H. H means number of heat by number of heat plus number of mass. So this is known as heat ratio. Next question is what is cache heat? When the CPU refers to main memory and find that word or data in the cache memory, then it is called cache miss. Then what is called cache miss? CPU refers data or word does not found in the cache, then it is called cache miss. So we get here cache miss. We get the two definition of cache hit and cache miss. Next we will come with what is mispenality. The definition of mispenality is the extra time needed to bring the data into the cache from the main memory is called mispenality. That is the definition of mispenality. Now come to a problem. Suppose time to access cache memory equal to 100 nanosecond. Time to access main memory equal to 1000 nanosecond. Heat ratio equal to 0.9. You have to calculate average memory access time. To calculate the average memory access time, the formula is H into TC plus 1 minus H into TC plus TM. That is the basic formula of average memory access time. Here, from the given problem, we know that the value of H equal to 0.9. Time to access from the cache memory equal to 100 nanosecond, that is denoted as TC. Time to access from main memory equal to 1000 nanosecond. We will put this value here. So equal to 0.9 into 100 plus 1 minus H. 1 minus H is also known as miss ratio. So 1 minus 0.9 into TC, time to access cache memory, that is equal to 100 nanosecond, plus time to access main memory, that is 1000 nanosecond. So we have put all the values in the given expression, and after calculation we get 200 nanosecond. So using this formula we have calculated the average memory access time. Here is another part. The another part is we have to compute. Number 2 is efficiency of the cache memory. We will calculate the efficiency of the cache memory by the time to access cache memory by average memory access time. Average memory access time is also denoted as T average. So the value of PC will be 100. T average we get 200 nanosecond. So it will be 50% efficient. The cache memory is 50% efficient. Next, we will learn the type of cache memory. So the next module is type of cache memory. Mainly, there are two types of cache memories used in computer system. Number 1 is L1 and L2. Now, we will make a difference between L1 cache and L2 cache. L1 cache, it lies on the same chip with the processor or motherboard. So, lies on the same chip with the processor. But in contrast, L2 lies external to the processor chip. External to the processor chip. So L1 lies on the same chip with the processor. L2 lies external to the processor chip. Number 2, L1 is smaller. Here L2 is larger. Number 3, it is faster. It is slower. Number 4, largest bit ratio. Number 4, smaller bit ratio. So that is the type of cache memory, L1 and L2, and we make a difference between L1 and L2. Our next topic will be writing method. Next topic is writing method. There are two types of cache writing method. Number 1 is write through. Number 2 is write back. What is write through? Write through means update the main memory and cache memory at the same time. The main memory and the cache memory contain the same data. It is very slow because each time main memory need to be accessed. In contrast, what is write back? There only the cache location is updated. When it occurs, the location is marked by a flag called modify bit or dirty bit. Afterward, when the specific word is not needed in the cache memory or when the cache memory becomes full, the data are copied to the main memory for future use and the cache memory is formatted. So that is known as write back. In a word, we can conclude that write through means update the cache memory and main memory at the same time, and write back means only the cache location is updated, and when it becomes full, the content are copied into main memory and the cache memory becomes formatted. Next, we will go with mapping technique. Mapping. The topic is mapping. Mapping means the transformation of data from the main memory to the cache memory is called mapping. There are 3 types of mapping. Number 1 is associative. Number 2 is direct. Number 3 is said associative. What is associative memory? CPU first send a 16-bit address for a desired word in the cache memory. If it accesses the desired word or if the desired word is found, then the data is read and sent to the CPU. If data is not found, then main memory is searched for the address of that word. Then address data pair is brought into the cache memory and it is replaced onto an old data address pair. This memory is being accessed using its content. It allows to access each block of main memory. So it is called content addressable memory. So associative memory is also known as content addressable memory. Next, what is advantage? The advantage of associative memory is it is very easy to implement and it works very fast. And what is the disadvantage? The disadvantage is that it is very expensive because of additional storage of address with the data in cache. Here we have to store 16 plus 8 bit, that makes 24 bit for a 8 bit of data. So this is the disadvantage of associative mapping. Next, come to the direct mapping. Instead of storing total address of information with data in the cache memory, only part of the address bit is stored along with the data in the direct cache mapping technique. CPU generates a 16-bit address that is divided into 2 fields. One field is called index and the remaining part is called the tag field. When the CPU wants to access the data from main memory, it places an address. The index field of the CPU is used to access the main memory, and the tag field of the CPU is compared with the associative tag in the word from the cache memory. If the tag bit of the CPU cache matched with the tag of the cache, then there is a hit and the data is read from the cache memory. If there is a miss, the data is transferred from the main memory to the cache memory with the new tag value. So this is the direct mapping technique. So why the direct mapping comes? The advantage of direct mapping is it is the simplest type of cache mapping, since only the tag field is required to match that. It is less expensive because instead of storing 16-bit address, only tag is stored along with the data. Here 8 plus 8, that means 16-bit is required to store a 8-bit of data. Next, we will come to set associative. In case of set associative mapping technique, two or more words can be placed under the same index address. Under the same index address, two or more can be stored. But data word is with the data word along with its tag value. The number of tag data pair under the same index is said to form a set. If k number of data tag pair are stored in the cache memory, then it is called KOA set associative. Suppose under the same index address, if there are two pair of data tag pair, then it is called 2A set associative. If there are 4 pair of data address or data tag pair, then it is called 4A set associative. If there are 8 number of data tag pair, then it is called 8-way set associative. What is the advantage of set associative mapping technique? It is the highest hit ratio. Next, what is the disadvantage? It is very expensive in terms of increasing of the set. Next, I am giving an example to understand the different cache mapping technique. Suppose the given problem is CPU generate 28-bit address. Number 1 it is given. Number 2, the size of the cache memory equal to 1 MB. Number 3, block size equal to 120 bytes. Number 4, 8 block in a cache set. Now you have to calculate or you have to determine the subfield in associative, direct, set associative. So this is the given problem. To find out the solution, first we have to write down CPU generate how many bit of address? CPU generate 20 bit of address. Next, in case of associative mapping technique, there are two fields. One field is known as index, another field is known as data. We will get the value of the data from the block size. Here, block size equal to 120 bytes, that is given in the problem. From the block size given 120 bytes, we will convert it into 2 to the power 7 bytes. From here, the 7 bit will be used to represent the data field, and the value of the index field will be 28 minus 7, that is 21 bit. So we have determined the subfield under associative mapping technique. The data field is calculated from the block size. The given block size is equal to 120 bytes, and we have to calculate the 120 bytes into 2 to the power 7 bytes. From here we get the value of data field equal to 7 bit, and from the given problem we know that the total address equal to 28 bit. So we get the remaining index field equal to 28 minus 7, that means 21 bit. So under associative mapping technique we get the value of index field equal to 21 bit and data equal to 7 bit. Now come to direct mapping technique. So next one is direct mapping technique. In case of direct mapping technique, there are three fields. Number one is tag, number two is block, number three is data. From the previous solution, we get the data field equal to 7 bit. So remaining there is 28 minus 7, that is 21 field. Under 21 field, some bits are for tag value, some bits are for block value. So first calculate the block field. To calculate the block field, first we have to calculate the size of the cache memory by block size. This is the formula to calculate the block field. To calculate the block field, we have to calculate the number of blocks that are present in the cache memory. If we can calculate the number of blocks present in the cache memory, then we can get the value of the block field. From the given problem, we know that the size of the cache memory is 1 MB and block size is 2 to the power 7 bytes. So 1 MB will be converted as 2 to the power 10 into 2 to the power 10 bytes by 2 to the power 7 bytes. So from here we will get 2 to the power 13 bytes, and these 13 bit will be used to represent the block field, and we will get the value of tag field will be 28 minus 13 plus 7, that is equal to 8 bit. So under direct mapping technique there are three fields. One is tag, another one is block, another one is data. We know that the value of data equal to 7 bit. The remaining 21 bit will be used as tag and block. So to compute the block, we have to calculate or we have to determine the number of blocks present in the cache memory. We get the number of blocks in the cache memory is present equal to size of the cache memory by block size. Here the size of the cache memory equal to 1 MB and the block size is 2 to the power 7. After calculation, we get the value of the block will be 13 bit and the value of tag will be 28 minus 13 plus 7, that equal to 8 bit. So next comes to set associative. In case of set associative mapping technique, there are three fields. One is tag, set and data. We know that the value of the data is 7 bit. The remaining 21 bit will be used as tag and set field. To calculate the value of set, we have to calculate how many sets are present in the cache memory. From the given problem, we know that 8 block equal to 1 set, 1 block equal to 1 by each set. So there are 2 to the power 13 blocks, so 2 to the power 13 by 2 to the power 3 that means 2 to the power 10 set that is present in the cache memory. So from 2 to the power 10 will get the value 10 bit. So remaining will be 28 minus 10 plus 7, that equal to 11. So we will get the value of 11 bit that is used as tag field. So we get the different subfield in case of associative, direct and set associative. From this lecture, if we summarize what we have learned, first we have learned what is cache memory definition. Number 2, need of cache memory. Number 3, how it increases the speed of execution. Number 4, performance of cache memory. Performance of cache memory is known as, calculated as bit ratio. We always known as what is miss ratio. Number 6 is what is mispenality. Then we have worked out a problem on mispenality, that is problem. Next one is the different writing method of cache memory. From the writing method we have found that there are 2 types of writing method. One is write through, another one is write back. Next we have learned about mapping. We have learned about different types of mapping, that is associative, direct and set associative. And finally we determine the subfield from a given problem, and that concludes the lecture 2.